Okay, good morning, all of you. In last section, we had discussed superposition theorem. In that, we had discussed dependent source as well as the mixed source example. Okay, today's session we'll see the Thevenin theorem. How to apply Thevenin theorem to electrical network. In that, we'll see how to calculate the current or voltage in particular electrical network by using Thevenin theorem. Right. So I'll share my screen and then we'll start our today's session. My screen is visible. Okay, then what is meant by Thevenin theorem? Okay, first of all, we'll see what is the Thevenin theorem. Thevenin theorem. Okay, you know that Thevenin theorem you have already studied in BEE. In any linear resistive network consisting of dependent as well as independent sources. Okay, it can be replaced at a given pair of terminal by an equivalent circuit that is consisting of only an independent voltage source in series with the resistance. That is the statement of Thevenin theorem. Okay, so only one independent voltage source is there. That is nothing but your VTH, and that voltage source it should be connected with some resistance. That is nothing but your RTH. Means any linear resistive network, you have to replace by only one equivalent circuit that is consisting of only one independent voltage source that is nothing but your VTH and that voltage source in series with some resistance that is nothing but your RTH. Okay, in this circuit the voltage source in series with resistance is known as that is the Thevenin equivalent circuit. Means this voltage source is called as a Thevenin voltage that is denoted as VTH and resistor in the Thevenin resistance is denoted as your RTH. This VTH is nothing but your Thevenin voltage and resistor, whatever resistor is connected to the series, that is nothing but your RTH, that is your Thevenin resistance. Okay, suppose that Thevenin equivalent circuit is connected with some load. Suppose if you connecting some load to the Thevenin circuit, suppose this is your RL, that load we have connected to the equivalent circuit. This is your VTH and this is your RTH. Okay, this is your Thevenin circuit. That load we have connected to the Thevenin circuit. Suppose if you find out what is the current flowing through the load resistors RL, then you can easily find out what is the current flowing through a load resistor RL. That is your RL. Okay. Suppose if you finding out the current flowing through RL, how to find out the current flowing through RL? IL over here. The current flowing through IL to the load resistor is nothing but what? Your voltage VTH divided by your total sum of resistance. That is nothing but your RTH plus your RL. That way you can easily find out the current flowing through a load resistor RL. Okay. Then we will see how to apply to electrical network and what are the steps to applying the Thevenin theorem to the electrical network. The step number one is what? To find out VTH. Suppose in any linear resistor networks, the aim is what? You have to find out the either voltage across the load resistors or current across the load resistor. My voice is clear.
Yes, sir.
Yes, sir.
Yes, sir.
Suppose if yes, suppose if you find out the current flowing or voltage across RL, that time we have to apply the Thevenin theorem, right? The step number one is what? You have to always find out what is your VTH. The step number one for applying the Thevenin theorem. Step one is what? Find out or to find VTH. That is our step number one. So how to find out VTH? In any linear resistive network, suppose if you have assume here a network that is a complex network we said. Suppose if you find out the VTH, then how to find out? Whatever load resistors are connected in electrical network, you have to remove the load resistors RL. Okay, the step number one is what? We have to remove RL for finding out VTH. Remove RL. Remove and find find open circuit. Find open circuit VOC. Okay, that open circuit VOC is nothing but your Thevenin voltage VTH. Okay, so we consider a point A and B over here, the polarity positive negative here, and that is your open circuit voltage VOC. Means open circuit VOC is nothing but your Thevenin voltage. Okay, so now VOC is nothing but your voltage across point A and B is nothing but your VTH. Is nothing but your VTH. That way you have to find out VTH across a open circuit. Okay. The step number one is what? Find out VTH. How to find out VTH? Remove the load resistor RL and we have to look it back into the network, whatever open circuit is there, and you find out the voltage across the open circuit terminal. That is nothing but your VTH or Thevenin voltage. Right. The step number two is what? Step number two. Step number two. We have to find out RTH. To find RTH. To find RTH. How to find out RTH? Here, suppose if we have a electrical network over here, that is we consider as a network with source or uh, your network we called as open circuit. We keep it as it is. Load resistor we have to open, and here your RAB. Okay, so finding out RAB, the one steps you have to keep in mind, making all sources off. Okay, making all sources is off. It is statement for only independent source present in your electrical network. Okay, it is present only independent source present in electrical network. Suppose the dependent as well as independent source is present in electrical network, that time step is different, right? You have to keep in mind. Suppose electrical network is only consisting of independent sources, that time we have to making all sources to be turned off, right? So now the resistance between open circuit is nothing but your AB. That is nothing but your Thevenin resistance. That is we denoted as your RTH. Okay. So now you have to finding out open circuit ROC is nothing but your resistance. Point A and B is nothing but your RTH. That is your step number two. If you getting VTH and RTH, you have to replace the network by Thevenin equivalent. Okay, the step number third is what? We have to replace the network. That is step number third. if you're getting VTH RTH, just you have to replace the VTH RTH value into Thevenin equivalent circuit. Okay, this is your Thevenin equivalent circuit, VTH and your RTH. Okay, the point A and B, suppose if you consider here, and you have to connect whatever load you have to remove, that you have to connect it. That is your RL. Okay, the current flowing through RL is nothing but IL, and suppose if you consider here voltage load VN. Okay, that way you have to replace the network. Okay, then you can easily find out the what is the current flowing and what is the voltage across area by using basic formula Ohm's law, the current divider rule, voltage divider rule, and so on. Based on that, you have to easily find out what is the current across load resistor RL, what is the voltage across load resistor RL. That you can easily determine. Okay, so now we will move on our example. It is clear steps. This step is particular for the independent sources. Is this clear? The steps. Is there any doubt in that?
Clear.
First step is what? Finding out VTH. How to find out VTH? We have to remove the load resistors, looking back into the network and finding out voltage across open circuit. That is nothing but your Thevenin voltage. The step number two is what? The RTH. How to find out RTH? All sources is to be turned off, and whatever the open circuit, that again you looking back into the network and you find out the resistance across point A and B, that is nothing but your Thevenin resistance. Again, if you getting the value of RTH, VTH, that you have to replace in Thevenin equivalent circuit and connected load, and you can easily determine the current flowing through a load resistor and voltage across the load resistor, right? So we'll move on our example. Suppose in this circuit, you obtain Thevenin equivalent circuit. Okay, uh, the point A and B. This is your Thevenin equivalent circuit. Point A and B. There, 7 ohm, 5 ohm, 5 ohm, 10 ohm. You obtain the aim is what? You obtain the Thevenin equivalent circuit for the active network shown in figure between point A and B. Means our aim is what? We have to obtain the Thevenin equivalent circuit. Thevenin equivalent circuit means what? We have to obtain VTH and RTH only. Okay. So now the step number one is what? Step number one is we have to find out VTH. We have to find out VTH. Okay. How to find out VTH? Suppose if we see observed over here, point A and B. Point A and B is your open circuit. Okay, open circuit terminal. That is already open. To find out A and B is nothing but your VAB is equal to your VOC is nothing but your VTH. Okay, suppose if you consider a path from point B to A here. Suppose if you consider a point path B to A over here, the consider a path from 7 ohm to 5 ohm resistor. That we have to denote it as a dotted line. Then VAB is nothing but your what? VOC is nothing but your V7 ohm plus your V5 ohm. Okay, but what you have observed over here, the point A is your already floating point. Okay, means therefore there is no current flowing through point A terminal. Means that is zero. Means this is your 5 ohm resistor as a floated a point A. Means there is nothing is connected at the outside. Okay, means point A is your floating point. Means there is no current flowing through a point A. Okay, means that 5 ohm resistor should be 0. Means what is your VAB? VAB is nothing but your V7 ohm. Okay, is this clear? VAB is equal to V7 ohm. Okay, then you have to apply KVL. How to apply KVL? Suppose if you starting a 10 volt source through a 5 ohm resistors to a 7 ohm resistors. So now we apply a KVL to loop, that we have only one loop in this circuit. Suppose if you starting from 10 ohm 10 voltage source minus your current flowing through a 5 ohm resistors, that is 5I. Suppose if you assume here I, okay, 5I minus 7 is equal to 0. Then you can easily find out what is I. I is nothing but your what? That is 10 by 12 ampere. 10 by 12 ampere. That way you have to find out what is the current flowing through a loop. That is 10 by I. So now our aim is what? Our aim is to find out V7 ohm, right? V7 ohm we have already calculated in step number 1. That is V7 ohm is equal to, that is V is equal to I into R. R is what? That is 7 ohm, right? Means I we have already calculated what is the current flowing through loop, that is 10 by 12, 10 by 12 multiply by your 7. Means what is your V7 ohm? V7 ohm is nothing but your, maybe if you calculate it, that you'll get 35 by 6. Means V7 ohm is nothing but your what? VAB. VAB is nothing but your what? That is your VTH is nothing but 35 by 6. You will get here 5.83 maybe. 5.83 volt. That way you have to find out VAB. Okay, that is our step number 1. Okay, is this clear? Is this clear, you people? Is this clear? Yes.
Yes, sir.
Is this clear? I'm asking you people. Please respond.
Yes, sir.
If any doubt, please ask. Right. This is simple example actually for independent source. That 5 ohm, why we are not considering here 5 ohm? Because that is a floating. There is no current flowing through open circuit terminal. That we have already studied the basic concept in open circuit and short circuit. Okay. Only 7 ohm resistor is present. Then VAB is nothing but your V7 ohm. That, then first of all we have to calculate I. We how to calculate? We have to apply KVL to first loop. Then we finding out here I is equal to 10 by 12 ohm. According to the Ohm's law, V7 ohm, I is multiplied by your V7. I we have calculated in earlier, that is 10 by 12 multiplied by 7. Means that you getting VTH. Okay. So now step number 2 is what? Anybody tell me step number 2?
Finding
What is step?
RTH.
How to finding out RTH? How
Making
to
all
finding out RTH?
making all sorts of
Making all sources is turn off, right? Here only one independent source is there. We have to turn off. Means voltage source is there. It should be a short circuit. Fine, fine. Point A and B here 5 ohm, 5 ohm, and here 7 ohm resistance. Okay, making all sources to be turned off, right? 5 ohm resistor, 5 ohm resistor, 7 ohm resistance. Then you can easily find out the what is the total resistance of this particular electrical network. Means how to find out RAB? RAB is nothing but what? That is 5 parallel with 7. 5 parallel with 7 and series with 5 ohm resistor. Then you can easily find out RAB. RAB is what? That is 5 multiply by 7 divided by 5 plus 7 plus 5 plus 5. You will get here maybe 95.12. Okay, that is nothing but here 7.92. 7.92. Okay, that way you have to find out RAB. Okay, then what is our step number third? Step number third is what? Yes, step number third. Step number
Thevenin,
third is what?
Thevenin circuit.
We have, yes, replace the network by its Thevenin equivalent. Barabar, right? Means whatever the value you have get it, that is VTH RTH, just we have to replace by Thevenin equivalent. Okay, this is your VTH and this is your RTH. Point A and B. So now we have already calculated VTH. That VTH value you know that is a 5.8. VTH value is 5.83. 5.83 and RTH is nothing but what? That is 7.92. 7.92. That way we have to replace the Thevenin equivalent circuit. Th- That is our aim that we have to satisfy. Our aim is what? To obtain the Thevenin equivalent circuit. We obtained the Thevenin equivalent circuit that VTH value is 5.83 and RTH value is 7.92. Is this clear? Example, is there any doubt in that?
Yes, sir.
Clear?
Yes, sir.
Clear? Clear?
Yes, sir.
Yes, sir.
Okay. So we'll move on our next point. So Thevenin theorem with the mixed source. Okay. Earlier, what we have seen that is Thevenin theorem is for only independent sources, right? The next we'll see the Thevenin theorem with the mixed source. Thevenin theorem with the mixed source. Okay, the step number one is what? Whatever method we have to follow in earlier, that same method you have to apply over here for calculating VTH. The step number one, as it is, you have to follow for the mixed source. The step number one is what? To find VTH. To find VTH. So finding out VTH, suppose if you have a network with mixed source, network with a mixed source, the same method you have to apply. You have to remove the load resistors RL and the point A and B is open circuit over here. The voltage across a point open terminal A and B, that is nothing but your VAB, that is nothing but your VOC is nothing but your Thevenin voltage. That is VOC is nothing but your VAB is nothing but your VTH. Okay, that is equation number one. Okay, the same method we have to apply. We have to remove the load resistors and we have to calculate voltage across the open circuited terminal, that is VOC is nothing but your VAB is nothing but your Thevenin voltage source, that is nothing but your VTH, right? The step number two is what? The step number two is slightly change in the mix source. Okay, just keep in mind, don't be confusing between mix source and uh, dependent source, right? So finding out RTH, to find RTH in step number two, so how to find out RTH related with the mix source? Suppose if you have a network here, given network, in given network, if we have a load resistors over here that we have open, whatever steps number one you have to follow, that is point A and B, we have to open, or we have to open the load resistors RL. Whatever load resistors you have open, that you have to short circuited over here. Okay, means you have to short circuited point A and B. Keep in mind, we have to short circuited at a point A and B over here. For short circuited, some current is flowing. That is short circuit current. That is nothing but your ISC. Short circuit current ISC. Okay. By using this current ISC, you can easily determine RTH. How to determine RTH? Here, you will get ISC, then you can easily determine RTH. How to determine RTH? RTH is nothing but your what? V by R. That is VTH divided by your ISC is nothing but your VTH. Very simple. Just you have to keep in mind the steps. Suppose if you find out RTH, we have to short circuit the load resistors RL, and we have to finding out the current flowing through a short circuited. If you get it the short circuit current, then you can easily determine RTH by using VTH divided by your ISC. Okay, the step number third is what? Step third is what? You have to replace the network by Thevenin equivalent. Okay, to connecting your whatever you load register you have removed, that you have to connect it again, a point A and B. Okay, so we have to replace the Thevenin equivalent circuit over here, positive, negative. Your VTH, your RTH, you have already calculated in step 1 and 2 respectively. Point A and B over here. Whatever load registers you have removed out, that we have to connect it over here, RL, and your current IL over here, and your voltage across load resistors. Then you can easily determine by using a current divider rule, voltage divider rule, Ohm's law. Uh, so current flowing through your load resistors RL and your voltage across the load resistors VL. Okay, these are the steps for the mix source. Is this clear? Is this clear, the difference between independent source and the mix source?
Yes, sir.
Independent source, we have to calculate VTH as it is in the mix source, right? Means for calculating VTH for mix source as well as the independent source, we have to follow the steps, same step. But for mix source, for finding out RTH, we have to short circuit it. We have to short circuit it, the load resistors RL. But here, one things you have to keep in mind: you don't turn off the sources. The sources it should be turned on over here. There is no sources to be turned off for the mix source, right? But in independent sources, for calculating ITH, we have to turn off all the independent sources. We have to turn off all the independent sources. But for the mixed source, you don't turn off any dependent or dependent independent sources. Means source it should be turned on, but load resistors you have to short circuit it and you have to find out the current flowing through a short circuit. Is this clear?
Yes, sir.
Clear? Okay, fine. So now we'll move on our example. So now example is what? The example one. Find IL in the given circuit by using Thevenin theorem. Find IL by using Thevenin theorem. Okay, this is the aim you have to find out. You have to find out IL. Okay, so now I'll draw the circuit diagram. Fellow, here your IL. 18 ohm. Here your resistor. That is 3 ohm. Negative, positive. Okay, in this electrical network, we have two sources, right? One is an independent source, that is a 24 volt, and another is a dependent source, that is your 3V1. That is a voltage control voltage source. V1 is your controlling parameter in this electrical network, right? So, as per the statement of Thevenin theorem, you have to find out what is a VTH. So, VTH, the step number one is step number one to find VTH. To find VTH. So how to find out VTH? We have to remove the load resistors. The load resistor is already given, that is a RL is nothing but the 12 ohm. Right? We have to remove the load resistors. But controlling parameter is what? Here V1, 3V1. Right? V1 is given already. V1 is given, the polarity is from positive to negative. So we have to assume V1 is nothing but your V1 dash. Okay. So we have to remove the load resistors over here. From positive to negative, that is point A and point B. A 24, 6, 6, 3, V1 dash, 18, current I, and here resistance, that is V1 dash, positive, negative. Suppose if you select the path from point B to A, okay, we have to select the path point A and B, B to A. So now you have to apply KVL to the input loop. Okay. Input loop is what? That is here. This is your input loop. Okay. So what is your KVL at input loop? That is 24 minus 6i minus your 18i is equal to 0. Means I you will get here what? 1. I you will get here 1 ampere. Okay. So now you have to finding out what is the voltage across VAB. VAB is nothing but what? Is this clear? I is equal to 1 ampere. Is this clear? I is equal to 1 ampere.
Yes, sir.
अरे यार बोलिए तो एटलीस्ट बोलो तो रिस्पॉन्ड तो
Yes,
कीजिए
sir.
यार. Why
Yes,
you're
yes.
not responding? I don't. How I am able to hear understood or not? Then VAB. Then now we have to find out the voltage across point A and B. So now if you start from 3 ohm resistors over here, that is V 3 ohm plus V18 ohm plus यहाँ पे 6 है 6 है 6 ohm V6 ohm minus the V1 dash. Okay, that equations you are getting right. But what you have observed over here, point A and B are open. Whatever we have seen in the last example, the same methodology you have to apply over here. The point A and B are open means there is no current flowing through a 3 ohm resistors. Then V1 dash is equal to 0. Means यहाँ पे क्या होगा आपका V1 dash is equal to 0. Means there is no current flowing through here. There is no current flowing through here, right? Here, here. Means this point A and B are open. Means there is no current flowing through output side, right? This V1 dash is equal to 0. Means there is no current flowing through 3 ohm resistors as well as your 6 ohm resistors. Okay, means these are the 0, 6, 3 ohm, and that is 3V1 and 3 ohm resistors. Means VAB is equal to what? VAB is equal to your, this is 0. V18 is what? V18 is present because some current is flowing through 18 ohm resistors because of your first loop, right? That is I multiply by 18, I multiply by your 18 plus V6 is what? 0. Then minus 3V1 dash, it should be 0 again. Means what is your left? Only 18. Means VAB is nothing but what? 18. Is this clear? VAB is nothing but your 18. Is there any doubt in that?
No, sir.
Okay, then what the step number 2? Step number 2 is what? Step number 2 to find the RTH. I already told the RT how to find out RTH. The load resistor should be a short circuited. Load resistor should be a short circuited, right? So now you have to short circuited the load resistors. So don't turn off all the sources. The sources it should be turned on as it is, right? That you should keep in mind. That is 3. Suppose the controlling parameter we have assumed 3V double dash. Positive, negative, 24 volt, 6 ohm, 6 ohm, 18 ohm, and load resistors, whatever open resistor, open circuit is there, we have to short circuit at the load. Okay, that is nothing but your IS, the current flowing through a load resistor, IS. Point A and B, your current I2, your current I1. I1, here one resistor is there, that is 3 positive negative V1 dash. Okay, so now V1 dash is nothing but what? So first of all, you have to calculate the controlling parameter. In mesh analysis, we have seen nodal analysis, we have seen superposition theorem, we have to see for the controlling parameter, you have to always calculate first. Means V1 dash is nothing but V1 dash is flowing through a 3 ohm resistor, but the current is from positive to negative means 3. The current is I2, is 3 I2. This is your V1 dash. Suppose the current is minus and plus, is that time minus 3 I2 is there. That you have to keep in mind. Okay, I gave one example in your tutorial number 2. The polarity is from minus to plus. That time you have to take the controlling parameter from negative to positive, not from positive to negative. That time the polarity should be minus. Then what is your ISC over here? ISC is nothing but your I2. ISC is nothing but your I2. Okay. So now you have to apply a KVL to first loop. So what is the KVL to first loop? KVL to first loop, that is 24 minus KVL to loop 1. 24 minus 6 I1 minus your 18 I1. Again that 18I is common between 1 and 2. So minus plus here, that is 18I2 is equal to means is equal to. Means you have to find out here, simplify minus 24. Then I1 will get 18, 6, 24 I1 plus 39. That you will get. Okay. 24 minus 24 I1 plus 18 I2 is equal to 0. Now you have to apply KVL to loop 2. How to apply KVL to loop 2? You have to start from positive to negative, means minus 18 I2. Okay. KVL to loop 2 minus 18 I2 plus 18 I1 minus 6 I2 minus PV double dash minus 3 I2 is equal to 0. Here we have already calculated 3 V double dash. V double dash is here. Okay. V double dash is nothing but what? That is 3 I1, 3 I2. That you have to put up in that equation. Okay, then you will get minus, you have to simplify this equation. 27 I2 will get plus 18 I1 minus 3. V1 dash is nothing but what? That is your 3 I2. 3 I2 is equal to 0. That you have to put up, and then you have to simplify. After simplification, you will get 18 I1 minus your V3 gets multiplied means 9. You will get 36 here. 36 I2 is equal to 0. That is your equation number. Means you will get I1 if you, that is nothing but 2 I2. If you solve the equation number 1 and 2, then you can easily get I2 value, I1 or I2. But I2 is nothing but what? I2 is nothing but your ISC. So after solving equation number 1 and 2, solving equation 1 and 2, you'll get I2 is equal to zero point 0.8 ampere. That is nothing but your ISC. Means ISC is nothing but your what? Zero point 0.8 ampere. ISC is nothing but your zero point 0.8 ampere. If you get the value of ISC, then you can easily find out RTH. How to find out RTH? Then now our aim is what? Finding out RTH. How to find out RTH? Is there any formula? How to calculate RTH here? That is nothing but your VTH divided by your ISC. 18 divided by your 0 point 0.8. That is nothing but 22.5 ohm. Okay. That way you have calculated RTH. So now the step number third is what? We have to replace the Thevenin or replace the network by Thevenin equivalent. So we have to replace network by a Thevenin equivalent. That is RTH, VTH is what? 18. RTH is what? That is 22.5. And load resistors we have connected as it is. That is your 12 ohm. So the point A and B is there. So now our aim is what? The current flowing through a load resistors RL. The current flowing through a load resistors RL means the current flowing through a 12 ohm resistors. The current flowing through a load resistors, you can easily find out IL is equal to your voltage 18 divided by your sum of resistor is what? 22.5 plus your 12. So now you will get IL is nothing but your 0.52 ampere. That way you have to find out the current flowing through load resistors RL by using the Thevenin theorem. Okay, is this clear?
Yes, sir.